Right, so we have taken out the images from our dictionary. The next step is to get patches out of those images. So let's define a patch size as 16 cross 16. So my autoencoder will work on 16 comma 16 images, but I'll linearize them, I'll vectorize them before I present it to the autoencoder. So it's basically an autoencoder that has a 256 unit visible layer. Now the function that I'm going to use to extract patches out of images is the view as windows function, which is present in skimage in the util submodule of that. So a window is just another name for a patch. It's defined as an overlapping patch. So if you give view as windows an image along with the patch size that you want, what it will give you out is a numpy multi-dimensional numpy array that contains all these individual patches. And there's also a step parameter that you can define there. It will allow you to skip pixels between two patches. So what I mean by that is, if you have the first patch, the second patch is just not shifted by 1 pixel, you can have it shift by more than that. I'll be using that because I want to save on memory here. So let's define OLS patches as what we want. We have many images, so we'll have to run view as windows one by one on each of these. So let's write a list comprehension for im in OLS images. But OLS images has the image iterator, the index that goes over different images in the last place, so I will have to bring that to the first place. For that I'll use np.roll access and bring the -1th index to the 0th place. And now I'll use view as windows util dot view as windows, run this over im for our patch size and keep the step size as 4. So let's run this. It ran. OLS patches is currently a list of ND arrays. I want to have it as an ND array itself. So this will take some time to execute. In the meantime, so I can see the shape here now. OLS patches dot shape. So you can see it has 5 indices. The first 3 define which patch it is, and the last 2 define which pixel it is within a patch, right? So our patches are supposed to be 16 cross 16, so the last 2 indices are 16 comma 16, and the first 3 are telling us that from each image of the Olshausen set I extracted 125 into 125 patches. This is not the patch size, this is the number of patches that has been extracted. So let's keep n patches for storing the number of patches. np.prod ols underscore patches dot shape, the first 3 indices of that, and viz will store the size of a patch. ols underscore patches dot shape 3 till the end. Now I like to change the dimensions of OLS patches to just 2. The first dimension will iterate over different patches, while the second one will move within a patch. So it's just a matrix now with patches arranged as rows. Just is equal to np dot reshape. We can use the reshape method of the object. Patches dot reshape n patches comma n viz. So see the shape of OLS patches now. Right, so 156250, this is the number of patches that we have, and 256 is the length of a vector made from linearizing this patch.